All right, the word transformation speaks of change. Things are changing. So when we talk about changing graph, the look of a graph, it's formally called a transformation. So a synonym for transformation is change, just like in English. So we're going to change up the look of the graph. What happened to the graph? That's what we're going to do. And there's universal variables they use to talk about all the changes. And the number could be whatever. Any real number could live where this h is. But for you to know, I'm talking about the horizontal translation of a function. They call it the h. And that's kind of nice, right? This is absolutely nothing to do why they use the variable h, and it's not like the law. It's just the practice. Like when you see an h in a story, you know it's gonna make a horizontal translation. That doesn't mean h can't be used as a variable another way, but you know how we always use x and y, and we always use h, okay? So h has a meaning in Mathlish. H is what's being subtracted from your x value in order to change this graph. Well, what is the graph? We don't know. It's any function. F of x is just another word for function. So when I go messing with the x, that's a horizontal translation. When you had translations in geometry, they called them slides, right? You just slid the picture over. That's another word. Or they could call it a shift. Or they could call it a move. In other words, the picture stays the same. It just moves around depending on what's being subtracted from h. Why do they subtract it? Because the nature of the graph, when you mess with the x, you take away a positive number, it moves to the right. So when h is positive, that v is pretty nasty there on that word positive, isn't it? It's like a check mark instead of a v. Okay. There you go. This means h is greater than 0. That means positive. That's English for these symbols, right? Correct? Yes? Then the graph shifts to the right h number of times. So h is a number. Okay. When h is positive, what does it look like in the function story? It looks like it's being subtracted. That subtraction is a part of the translation, not h. H is positive. When you see x minus 4, that means it's going 4 right. And how do I remember it's not normal? I call it crazy. Now, I don't know, maybe you've had ex-boyfriends or girlfriends before. Would you think they're kind of crazy? Yeah, perhaps. Maybe they're not. Maybe just you had a peaceful separation. But that's how I remember. My exes are crazy. If they're still alive. Some of them aren't. Anyway, yeah, that's a joke. But it helps me remember that x is crazy, okay? So when you're messing with the x, it's not what you see, it's what you know. You know that when you see a plus, like this guy, you see that plus there? H is really a -3. So when h is negative, that's what this symbol means. Then you move to the left. So I don't know what color you want to use. It's too hot pink. it shifts the whole graph, blah, 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 left. And you don't take the negative, you know, if h is a negative 3 like it is here, you just move 3. It's like the going to Kearney. You don't go a negative 35 miles, you go 35 miles. That's why they have the absolute value sign here. They're saying don't make h a negative number, just move left what h is without the sign when h is negative. So I'm just going to go down here to this example. You see this? H is a negative 3. So when h is negative, it looks positive, but remember it's crazy. So you're actually moving left 3. So that's what that means. H is negative, you move left. Well, it doesn't look negative, but it is. Because what did it take h to equal to make this sign positive? A negative 3. So that's definitely Algebra 1. Got to remember that Algebra 1 idea. So what they did was take this original parent graph. I'm going to color my parent graph in orange here. This is my parent graph. It's the dotted line one. That's what an absolute value graph looks like if you don't mess with anything. Hasn't been changed at all. Got every graph. This is like a lesson in itself. This one right here. This is a lesson. It'll be our first function we'll deal with after we get done with these foundational ideas. Every function has a parent function that hasn't been transformed. And now this solid line here, I'm going to make him pink like my shading up there. He is the transformed function because you see this vertex? He went left 3. See that? So now he's his transformed self. So every point on this graph, the orange one, went to the left 3 units. Now remember, when you're working with your graphs, you will not have to draw them. You get to pick them. But if you want to think more deeply about this idea and say, sure, whatever. No, thankfully, this is true. You can check out desmos.com. Remember? I told you about that earlier. And then look up the graphing calculator, and you can see it for yourself. You graph those two functions in, and you'll see them happen. So don't be afraid to go exploring on your own and check out things. It's a great tool to help you know what is the true graph. Great, great homework helper. You won't be able to use it on the test, obviously, but it will build your confidence and you know what graph is correct. You know, because you've looked and looked and studied, and you can smell a wrong one in a minute. So this one is the hardest one. This is the one we'll make the most mistakes on because you'll forget X is crazy. So hopefully, I still have people coming back to me in the other classes and say, I got this. I remember what you said, Miss Fisher. X is crazy. Okay? And it's silly. You won't find it in a math book. But I made this game up in my head to help me remember the truth. And I hope you do that. Good mathematicians play those kind of games in their head. They make their own stories that fit the facts and then be able to remember them easier because they're your story. You go, oh, that's not so hard. Well, I'm going to throw all sorts of graphs at you. You should be able to do this with any graph. You should be able to watch it change. So we've got the horizontal translation belongs to H. X is crazy. When you see a subtraction, it's going right. When you see an addition, it's going left. Crazy. All right, this one is normal. Universally in most math ideas, again, this is not a law, it's just a protocol. If you're going to change a function graph vertically, it's normal looking. I add k, I go up k. And if I subtract, you see a minus number, it's going down. So that one is the next mistake. Let's see. I'm going to make k green maybe. Here we go. Green is normal. This number that's being added out here correlates with a vertical shift, move, change, right? So when I see a k, it says plus 3, I'm going up 3. Because k looks positive and it is positive. So this is where you'll forget. Just x is crazy. Remember what f of x is? Another name for f of x is y, right? The y change is normal. The reason is the y is the function already done, and then when I add and subtract, it just goes up or down like a normal elevator kind of thing, you know. What you see is what you get. But when you're cooking in here in the inside the house, inside the deep dark dungeon of the X story in here, that's when things are crazy. When they're looking opposite of what they really are. Okay, and so when k is negative, it goes down. So let's make that guy. I'm running out of light colors. How about red maybe? Kind of a light red. Okay, when it shifts down, when it's negative. Okay? And that's positive shipping. So this guy is, what you see is what you get. K is 3. You go up 3. The parent function is the v function, absolute value of x, right? This guy. That's before I changed anything. Then I take his vertex and every other point on his graph and go up 1, 2, 3. 1, 2, 3. Up 3. There he is. There's the new story right here. You can do that with a V, a line, a curve, anything. Any graph you transform, you can look at what it originally started with, that's the parent function, and then either you're messing with the x or you're messing outside the x story, i.e. you're messing with the y. Just remember, f of x just means y. Right? Remember, f of x is just y. So what I'm really doing here, you know, if I moved it over here, it looked crazy too, but it's not. It's on my other side, away from the y, so I'm adding 3 to the function, and so what you see is what you get. And this is the first time you've seen this stuff, guys. So you're not going to remember right away. But the more you get used to the ideas, then the better you'll be at spotting them. That's math. At this point in time, you don't have to prove anything. You know this is true and you're using it. Okay, so let's do some examples. Describe the translation of this parent function. This is a quadratic function. That's the dotted line here. And sketch the graph of the translated function. So I have to say, what way did they go? How far? So this is telling me I'm going left 1 unit. See, that tells me I'm going left. Crazy, huh? X is crazy. Right. So now I get to draw it. Let me see. Let's make him pink. Go. And if he starts here, I go left 1. And so his little vertex will be here. And so you see this guy? He goes left 1. So I'll have a good shot. This guy goes left 1. Find another nice one. Here's a nice one, goes left 1. This guy will go left 1. Now we just have to connect the dots. And remember, you just will have to find yours. I did a poor job this morning drawing mine, so I needed more reference points, they're called. I just drew myself some reference points. Remember, you can always check your answer in Desmos.com if you're not sure. You know, that's going to build your confidence. Could you do that? Now you know what to do, right? I didn't make a table. I didn't plug values in. That'll work too. But yeah, I could do it big picture like. That's what they want for you. Big ideas. Want you to see how things move in math on a graph in general. Okay, I helped you with that one. What is the move on the other one? Anybody want to be a willing sacrificial lamb volunteer? What do you think? What direction? Go ahead and shout it out. Right. Okay. And it's okay if you're not right, correct, but notice, isn't it? Isn't that okay? It's okay to make mistakes. It is. Yes. We all remain anonymous. Okay, now notice. Is that number H or K? Look up here. Is it inside the goobity gob or is it outside the original function? See this guy? He's the original. Am I taking 2 away from the inside of that guy? Or am I taking 2 away on the outside? Outside. You see that? See that? If I covered the function up, you see how the -2 is on the outside? But here, if I cover the function up, see, you can't see my number. So he's on the inside. And this is what we're learning, isn't it? What we're learning. Where is that guy living? So since it's on the outside, it's a K move. So it's either going up or it's going down. And remember, these guys are normal. What you see is what you get. What direction for number 2? Okay, it's either got to go. Okay, I'm going to write this out. This guy is K. So it's got to go up or down. This guy, he's H. Because he's inside where the X lives. You see where the X guy is here? Like this is X squared. Let's see if I can write that better. Go like this. See, X is still, nobody's touched the X story. It's out here, so that's how I know it's K. So up here, that's why we have notes. These are only two choices. And K is a -2. Here, H was a -1. Because I saw a plus, but it's crazy. Here, K is what it is. So what are we going to do? Up or down? Down. And remember, when we talk about the units, it's without the sign. Oh, I wrote up instead of units. Silly me. Started with a U. Okay. And you will get them. Your eyes will become educated. You will get this. So now we get a sketch. Let me see. The change is the green one. Okay. So if my vertex started at 0, I go down 2, make a new vertex. Here it's at 1, 1, so I go down 2. That's a new little curvy space. Here down 2. Here down 2. And I can kind of get a sketch in, but you all, your artistic ability can be supported by the fact you get a pictograph. You don't have to draw it. This is quadratic functions. We won't do these right away. We're going to do absolute value functions first. But they all have H's and K's if things change. I'm going. Are you ready? So that's the big deal. If you see a parent function here, see this guy? He's an exponential function. So the function itself is 2 to the x. That's what it is before any changes happen. And that's kind of waxy, like that. If I can mess with this glare or not. That didn't help any. It's still nasty. I shouldn't have colored it so heavy. Sorry. All right. So here's the question of the day. Is that number the H or the K? K. You see it? Yes. And it is what it is. So what direction are we moving? Yep. How many? Yep. Bingo. And then it's units. Glary. Wet ink. Okay. So now you pick some favorite points you like to pick on your graph. Let me see. It is K, so I'm going to use the green just to keep it up. Down 4. So I'm at 1. 1, 2, 3, 4. Go there. Here, this one. 1, 2, 3, 4. Go there. This one. 1, 2, 3, 4. See what I'm doing? Making my life easy. Okay, this one's going 1, 2, 3, 4. Very close to that guy. Exponentials never cross. This is called an asymptote. When it like has a boundary like that, you'll learn more about that. Just depends on that. These are like in the spring. You'll do these graphs, I believe. Exponential graphs when the variable's in the exponent. Makes an interesting story, doesn't it? Looks like a rocket taking off. Alrighty. So here, you see it messing with the x, friends? You see that? See how it's connected with the x? Yeah, it's see that? So that's an H. And it looks negative, but it's really positive. So if H is positive, what direction do we move? Good job. So it's really a big deal to decide who's the change in here. Is it H or K? And then you can talk about directions. That's why that story up above is so important to use. So we're doing a pink move. So everybody just goes over one to the right. One kind of goes here maybe. Goes a little off. So it zooms down to the same story, but the X shifted to the right 1 unit, and I missed that dot. That's kind of nasty. Pretty weak. Okay. Okay, our time is up. So we'll do the back side tomorrow, and then homework over the weekend. Okay? Have fun once you get it, once you get the clue, once you break the code. Big ideas are very simple, but it's knowing what the big idea is the